Hello, everyone, and thanks for coming to my poster on physics-inspired representation for atomistic machine learning. At the Cosmo Lab at EPFL, we try to incorporate as many fundamental symmetries of atomistic system we can into our machine learning models. And these fundamental symmetries are invariance with respect to global translations, equivariance with respect to rigid rotations, invariance with respect to atomic permutations, and a handful of other more exotic symmetries. We can encode these symmetries in our representation by using an atomic density instead of atomic positions, which already gives us invariance with respect to permutations. Then we can expand that density on an atom-centered basis, which gives us independence with respect to translation. And out of that basis, we can have a radial basis and an angular basis. And the angular basis is spherical harmonics, which, depending on how we do it, gives us either invariance or equivariance with respect to rigid rotation. We can use that, then use a spherical expansion to build a family of different representation with different guarantees, and use this representation in machine learning models. These machine learning models allow us to do very accurate and cheap predictions of the energy of a system, of forces of a system, or more interesting properties such as hamiltonian elements and orbitals, occupied orbitals of molecular systems. We already have an implementation of all of these ideas in the LibreSCO software, which is currently single-threaded and runs on GPU. And we are planning to work on making that software multi-threaded and making part of the calculations run on GPU and or using MPI distributed parallelism. If you have any questions about that presentation or poster, here is a handful of papers which you can read. And please send any inquiries to this email address. Thanks a lot.